Hello, class. I received a few questions concerning the binomial probability distribution function. So I wanted to put together a quick video to help explain some of the challenging parts. So let's take a look at an example. This is on page 337 in your textbook, example 3. It says, according to the CTIA, 25% of all U.S. households are wireless-only households, no landline. Actually, my house, we no longer have a landline. Everyone just has a cell phone, so this is pretty relevant. It says, in a random sample of 20 households, what is the probability that exactly 5 are wireless only? Okay, so if I randomly select 20 households, what's the probability that exactly 5 are wireless only? So if we were to do this by hand, this is the binomial probability distribution function. So some of you are not familiar with some of the symbols here, okay? Excuse me. The N, in this case, would be the 20 households. The 5 would be represented by the X, and the P is the 25%. Okay, so if we were to try to do this by hand, if you look at the next page, on page 338, you'll see they substitute the N with the 20, the X with the 5, the P with the 0.25, and so on, right? They use these values. N is 20, X is 5, P is 0.25. But here's the tricky part. What is this 20 capital C5, right? You might say 20 choose 5. Well, there's a formula for this, right? This NCX, or N choose X, can be written as N factorial, right? So it looks like N with an exclamation point, but it's really N factorial over X factorial times N minus X in parentheses factorial. That's a lot of work, right? If we were to do this by hand, that would be rough. So I'm going to show you how to use StatCrunch to handle this calculation. But even your calculator, see if I can bring one up, actually has this N choose X feature. If I press the math key on my TI-84, and if I hit the right arrow to highlight probability, I got to hit it a few times, you'll see this number 3 is N choose R. So if I were to press number 3, you see I can place the 20. Oops, my calculator just went blank. Hold on for 1 second. Okay, I think I have it back. Right, so I replace the N with the 20, and I press the right arrow, and I can replace the X with 5. So this 20 choose 5 is the same as this 20 factorial over 5 factorial times the quantity of 20 minus 5 factorial. So if I were to press enter right now, this large number, this 15,504, is what's represented here, okay? And then I'd have to multiply that by this 0.25 in parentheses, raised to the 5th power, and that would be times the 0.75, raised to the 15th power. And when I press enter, oops, I made a boo-boo. You see what happened? I forgot to put this as 0.25. So I have to redo that calculation. So let's do this one more time. If I press second enter, it will bring me back to this 20 choose 5. I press enter, and then I'm going to multiply that result times 0.25 raised to the 5th power. And that's going to be times 0.75 raised to the 15th power. Now when I press enter, look at, I received 0.20233, and that's what the book received, right? The book carried it out 4 decimal places. So we did get the same answer. Again, for some of you that are not familiar with the factorial key, I just wanted to show you where you can find that in your calculator. If I were to press, say, 5 factorial, so I press 5, I press the math button, I highlight the probability window, and look at number 4. It's the exclamation point or factorial, and I press 5 factorial, I get 120. That's really just saying 5 times 4 times 3 times 2 times 1, and you'll notice we have 120. Okay, so this is the long way to do this. Lucky for us, we have StatCrunch at our disposal. So I'm going to open a new StatCrunch window. And I am going to select Stat Calculators, Binomial, and I have a little window that comes up. And I forgot what the N was. I think N was 20. Let me just take a peek. Right, going back to page 337, example 3. Yeah, a sample of 20 households. Okay, so I'm going to make N 20. And I think it was a 25% chance, right? 0.25. Let's just double check that. Yeah, 25% of all US households were wireless. So there's my 25%. And we wanted to test the probability that X would be less than 3. I press compute. Oh, I'm sorry. Actually, it was less than 5. Excuse me. I jumped the gun. I press compute. I made another boo-boo. Not less than 5 equals 5, right? If you look at our textbook, it says exactly 5. I have to lay off the coffee, I think. Now I press compute, and you see our result is the 0.2023. That was the same result that we had in our calculator, 0.2023. And if you look at the example in the book when they worked this out for us on page 338, 0.2023. Okay, so StatCrunch was really helpful in handling the heavy lifting. Since we have the StatCrunch open, let's take a look at question B, right? Example 3. Question B, it says fewer than 3. So if I go back to StatCrunch and I change this to a 3, and fewer would be less than, right? I want to know the probability that X is less than 3. I compute, and my answer is 0.0912. And if you take a look in the book, question B, 0.0912. Okay. Now, if you were to do this the long way, you'd actually have to calculate the probability for 0, 1, and 2, and then add them up. Right. So instead of doing P of 5, you're going to replace this with a 0. So everywhere you see a 5 up here, all right, you replace all the X's with 0. And then you'd have to do the same thing with 1 and 2. So you're essentially doing this calculation 3 times, but with 0, 1, and 2 for X. And then you'd add those 3 values, and you'd end up with 0.912. I think it would just be easier to use StatCrunch. Let's take a look at one more problem. If you look at problem C, so problem B says fewer than 3. Problem C says at least 3. Well, if you think about it, if we sum all of the probabilities, we have to arrive at the total of 1. So if fewer than 3 came out to this 0.912, if I were to subtract 1 minus, let's use my calculator, if I were to do 1 minus 0.09126043, that would give me the rest of the probabilities, right? So the probability of fewer than 3 was the 0.0912. Probability of greater than 3 or equal to 3 would be 0.9087. And just to verify that, I'm going to put our calculator over here. If we change this to greater than or equal to 3, you see our result changes to 0.908, and that matches what we had in our calculator. Okay, so I hope you found this helpful. Thanks for watching.